Time should be here. It's okay. Now, see, therefore, if you remember well, this how we derive this is a lengthy process. Remember, from Clausius-Clapeyron equation, this, and then we didn't consider delta H is a constant. We consider that delta H is a constant is possible only when the delta Cp is 0. But if it is a non-zero, there are three possibilities, many possibilities. But if you go simple option is simple choice is delta Cp is a constant, then you have a three term and the term that comes as this type of thing that we have solved in the problem 1, you have seen. So, but we want to show here that alternative derivation and very quick and very easy. So you consider this, you write this solution right here itself. Solution A liquid. Achha, maybe I have to change the pen. I have to change the pen. Okay. Maybe A liquid goes to A vapor. See, you apply your chemical reaction. Apply delta G0 is minus RT ln K. You see what magic you get. Consider the equilibrium, right? As you write often, consider the equilibrium. Phase transformation equilibrium, which is as good as a chemical reaction, liquid to vapor. Now, what is this? Recall delta G0 is what? Minus RT ln K is what, right? Minus RT ln K. K is what? Equilibrium constant. So you have to write activity of a vapor divided by activity of a liquid, and you know very well that activity of pure liquid we are talking. So this activity will be one pure substance we are considering. And what is this? Is minus RT ln P vapor pressure. Activity is pressure. Gas is pressure. Activity P. Okay. And now what is delta G0 from our previous study? Recall what is the general Cp is a constant. Is a constant. Okay. What is the relationship? I am writing this. You can recall A plus Bt plus, tell me, Ct ln T. This was the relation. 5 term is 3. 5 term. When there is one term, 2 term, 4 terms. 1 term, 3 terms. A plus B plus Ct. This was derived. Previously derived, right here. So that gives you some comfort. Previously derived. This you know very well. Delta G0. So write this nicely here is minus RT ln PV, or ln PV is what? ln PV is LNP. ln PV is LNP. So called here LNP. The way you are written here is LNP. General speaking, is LNP. Is what? You tell me. A by minus RT. A divided by minus RT plus BT divided by minus RT plus CT ln T divided by minus RT. What it gives? You tell me. Here TT cancel. It is B by minus R. I call this A prime. I call this A prime right at the end. A prime. That's constant. No temperature. And that's A prime. Plus this is what? B prime by T. Plus this is TT cancel. C prime ln T. Shall I remove this? This is no longer important. Remove this part. This part. This is where you write. This should be removed. It should be removed. It should be firmly fixed here. It's okay. It's okay. Will this work anyhow? I don't know. No. So where what you say, where, right? Nicely, where this you clarify, where what is this? B prime is A prime is rather, I am very sorry, A prime is nothing but minus B by R. Check. B prime is what? Tell me. B prime is what? B prime by T is minus A by R, and C prime is minus C by R. No problem. Any name does not matter. So this is as good as similar to this A plus B C and F. This form. This is in the form. What? This you can in the form A plus. And B prime is you right. A prime is minus B by 5. Correct. This term is A prime. This term is A prime. A prime. This term is A prime. And A by minus R is B prime. B prime. Okay. C prime. So in the form A plus, it is same as A plus B by T. C. This form. This problem is also over. So last problem. On this assignment number 8. Assignment 8. So let me remove this side. It's not required. Okay. Problem 4. I think some problem still will be there. Problem 4. Last problem. You just write this. The melting point temperature of zinc. The melting temperature of zinc in an atmosphere of some inert gas at a pressure of 1 atmosphere is 420 degrees centigrade, as you know. This is the melting point of zinc, and in that state, as I was saying, the partial pressure of zinc that is the vapor pressure of zinc in the inert gas is 2 times 10 to the power minus 4 atmosphere. Very small value indeed. The molar volumes of solid and liquid zinc are respectively at the melting point are respectively 9.60 centimeter cubed and 9.88 centimeter cubed. Calculate the vapor pressure of zinc when the total pressure of the inert gas is increased to 2500 atmosphere. It's a large value, huge value. This is the question. Solution. So what in essence this problem is asking? So you know the vapor pressure of zinc at 1 atmospheric total pressure is 2 times 10 to the power minus 4 atmosphere. What will be this value at a higher pressure, namely 2500 atmosphere? So in a sense, temperature remaining same. In a sense, what is the effect of pressure on vapor pressure? So solution, okay. So the theme is okay. So objective. This is objective to study the effect of pressure on vapor pressure. Vapor pressure of a liquid or solid, okay, or solid. You know vapor pressure in dependence on temperature, you know very well. While you got, always you are getting this LNP versus temperature. All this all. Effect of pressure without changing the temperature, this is the problem. So let me sketch this problem so that it helps you understand. Oh, sorry, sir. So this is actually zinc is a bit. This is your zinc solid. This is your zinc liquid as it should be. Single component as you. This is your zinc. What you are plotting this side, temperature in Kelvin. You know, temperature in Kelvin. What is you are plotting this side? P in atmosphere. Achha. 1 atmosphere here actually. See, this is 693 atmosphere. Put a value of 1 somewhere, 1. So if you go this way, you go down this way, then this temperature would be the melting point. 693 as given. And you are doing what? Using this is the melting point where solid liquid coexist, 1 atmosphere. You are keeping the temperature fixed, you are increasing the pressure to a very, very hugely large value, like say, like say 2500 atmosphere. And obviously, you see, zinc solid will be the stable phase. That is not the problem. Problem is about vapor pressure. What is the vapor pressure? I am giving you a separate sketch that will be more helpful. That will be more helpful. See, you see, first case. Here you go. Here you go. This is your famous cylinder piston. You are used to this. total pressure is 1 atmosphere. You have zinc solid. To first line, inert gas 420, temperature is 420 degree centigrade, thermostatic arrangement as if 693 Kelvin, here 1 maybe. And what is here? Zinc vapor. And what else is here? Inert gas. Call it argon. Argon gas. Everyone knows. So what is the value of this zinc vapor under this condition given to you? What is the vapor pressure of zinc? 2 times 10 to the minus 4. See how small it is. Atmosphere. Then what is the contribution of argon towards the total pressure? 1 minus 2 times 10 to the minus 4. They together make the total pressure. So it is actually essentially, right? Essentially 1 atmosphere. Essentially. So this under 1 atmosphere, this is the temperature. Solid liquid coexist. Now one question you may ask. I'll take the second. Let me finish this question. You say, sir, this point, which point is 1 atmosphere 693? This point. Who are coexisting? No, sir, solid liquid, sir, makes sense, sir. Solid liquid you have written. Well, this is the melting point, sir. Very good. Justify this vapor here. There is no vapor phase. Actually, if argon were not there, then this zinc vapor, this pressure, it has a vapor pressure. The vapor pressure of solid zinc or liquid zinc you can always get at this temperature. This is the vapor pressure. And a solid is extrapolated. These are the vapor pressure. Vapors are there, but why it is not physically present, sir? This is very important here. You don't see because is much greater or greater the vapor pressure. It has condensed. If it are not present, if 1 atmosphere pressure, you never hope to that zinc vapor. So I say only you have these two. They have the properly again vapor pressure curve. Solid vapor pressure curve give you this. You have to extrapolate this, and liquid directly shows this is the vapor pressure. So these small vapor pressures are collapsed into condensed phase. So you never hope to see. But here you see, because this pressure now withstood by high pressure doesn't make it condense. So main load resist pressure. So share is almost full. So this can be answered also in terms of degree of freedom. I tell you, I should touch upon only the phase rule. Actually, here what has happened? You have a see. I tell you what. You have say okay. If you here the inclusion of argon into this system has increased the number of components. It is a single component diagram, but presence of argon makes it 2 component. The moment C increases, AP C minus P plus 2, just touching upon this, actually this is moreover I have not covered. The moment component increases, you see, degree of freedom increases. So you have a greater freedom, any pressure. Normally, any pressure, if argon were not there, you don't have any choice on the pressure because solid liquid actually vapor cannot be seen. But the increase of pressure, presence of this argon has increased the degree component number of components. So you can have a choice on pressure. You see here how many choice? Clearly see one curve. Yeah, one dimension, one pressure. If fixed pressure, temperature fixed, pressure fixed. So one, but here you get 2 types, 2 degrees of freedom because of the inclusion of the argon as the component, separate component, second component. So this is the answer. So now what is the figure 2? This goes to the second one. Second one is what? This is your real question is here about this. Oh, this is actually drying up. Oh, hold on. This should be get here. So second question, second part is more important than the first. Yes, real question. Second part is what? That let us sketch that second part of the question. I am drawing similarly. You just follow me. Draw this container. You know what you write here? I am writing zinc solid. You will explain why I am writing zinc solid. I am not writing zinc liquid. Zinc vapor as well, because that is the main thing of our discussion. Argon gas cannot be. And your pressure, what is the pressure? Next, this time, second case, think about this, 2500 atmosphere. Temperature has not changed. T is 693 Kelvin. Right here, figure 2. Figure 2, state 1, state 2 is better, it will be better. State is better. We are used to writing, referring to states. What is the pressure? Tell me here. 2500 atmosphere. 2500 atmosphere. Good boy, huh? And argon zinc vapor is okay. Can you tell me what is the pressure? This, acha, two questions arises. Two questions. Sir, why is the liquid, sir? I am not, why I am not liquid? These are equilibrium values. Liquid is where? Here liquid, here no liquid. If you look at the figure, there cannot be any liquid phase. Only solid. Solid. Vapor pressure of solid. Here whose vapor pressure? Again another mental block. Whose vapor pressure? Sir, any pressure. That's why they coexist. Vapor pressure means activity, means free energy, so they are intertwined. Fugacity, so intertwined. Equilibrium means all. So any either. But why you have not written? No, not either. Here only this is preferentially stable. So zinc. So that's why I have to consider zinc solid in the both cases and see effect. 2500 atmosphere is the pressure, that is external. What is this value, zinc vapor? What is this value? Not unknown, sir. This is unknown. So call it P. I have to change the pen perhaps. P. And call it P or P atmosphere, right? P zinc, right? Is P atmosphere. P means vapor pressure. Now what is 00 minus? Good boy. Now solve the problem. So we will see, since actually maybe I have to go to the other side, unnecessary, since I have a lot of space there, so I can write here. Lot of space here. Actually, I am running out of this, but I am changing this. Since solid is the only stable phase. It's a stable phase. Once more, let us try. 0 is the stable phase. At state 2, zinc solid, right? Not zinc liquid. Not zinc liquid is a stable phase at state 2. At state 2, we will consider the effect of pressure on zinc solid at the given temperature of, tell me, 693 K. How look at the effect of pressure on this? So now what is this? So recall this quickly. You already recalled a moment ago. dG is VdP minus SdT, and dGt is VdP, or d delta G. So what? Okay, let me check. Acha. dG is VdP is okay. That's okay. dGt is VdP. You write this. VdP is what? Recall. RT d ln fugacity. Okay. So you write this in terms of zinc. dG zinc solid. Since solid is our Okay, point of interest, the solid phase. The solid is what? V. Acha, I think I have to change this. The old one I have to bring in. The little bit clumsy. Ah, okay. This will not take much time. Almost over. Okay, let me here. DZ zinc is, tell me, VDP. You have to write also zinc, V zinc, DP. Also write similarly. This is recall. This is the very beginning of the fugacity. RT, D, LNF, zinc. Zinc is the species. Zinc is the species. You have to have a consider zinc as RTLN, This you recall. Typically, these vapor pressures are small. So what you can write? Next step for further simple, very okay, convenient simplification is what? Remember, fugacity at low pressure is pressure. So DLN P zinc, vapor pressure zinc. So you are all set. Now you have to integrate. Now you integrate or integrate this or write once more. This VZNDP, let me write nicely, is RTDLNP zinc. You integrate, no problem. What you will integrate? Two cases, one to state 2. Actually, you can write state 1 to state 2. What is this? What is the pressure? State 2. Achha, right here. State 2, state 1, state 2. Not bad. Now write. What is this? B zinc DP. B zinc I'm taking outside because this is not. I'm giving the value B zinc. What is the state? Oh, achha, right once more. B zinc DP. What is the state 1 pressure? Tell me. 1 atmosphere. BDP. Yes. Solid is exposed to solid zinc is exposed to 1 atmosphere and so much atmosphere. 1 atmosphere goes to 25. Nothing else. Atmosphere is RT, very easily, RT comes outside. RT comes outside. Shall I show this? RT come outside. T comes outside. RT outside. DLN, PZN. Can you tell me what is the state 1 PZN? State 1 PZN here before you. 2 times 10 to the minus 4. And what is the state 2? P. As I've said, PZN or P. I've written somewhere P. I've written here. Where? Here. PZN you can write also, no problem. P. Then unknown, the unknown. Or VZN can be taken also, not much, depending on pressure, volume, not much. Or VZN 2500 minus 1. What is the unit for this? Achha, VZN I'm writing next line. RT, 8.314. Achha, no, coming to this, okay, it will be later. You write here DLN is what? Ln P by 2 times 10 to the minus 4. Is okay, sir. This part okay. V, actually V. So here VZN is given solid. VZN, we're talking about solid. Solid is what? 9.60 centimeter cube. 9.60 centimeter cube per mole. So, but what you will right, keep it, retain it per mole. This will be very good. So, right here, or 9.60 times 2500 means 2499. 2499. Please put the unit here. What you write unit? Centimeter. Let's take a look first. Is okay though? 9.60 solid. Centimeter, tell me, per mole? Mole. And what is the unit? Atmosphere. So you clearly have it is cc atmosphere per mole on the left hand side. Right hand side you have to check. Right hand side will you VZN. Sorry, VZN is given right here, given. Slightly distracted here. So or here is equals to R is what? That you have to answer. See, this is Cc atmosphere mole. You have to reconcile. Good. No, if I don't, okay, if I liter, then what value of R you will consider? 0.082. 0. Why? 82 cc? This side is cc, that is also cc. 82, it's okay. 82, what is the unit, right? Cc, tell me, liter atmosphere per mole Kelvin. So Cc atmosphere mole Kelvin. T is what? How much temperature? Please tell me. 693 Kelvin. And next is what? Ln times ln P by 2 times 10 to the minus 4. 2 times 10 to the power minus 4. Okay. So what is the unit here? Can you cancel Kelvin and Kelvin? So what is this? Cc atmosphere per mole? Cc atmosphere mole. You are very satisfied. What is the unit for log term? Log term never has any unit. No unit. Log term are unitless. So this. So you are all set. So this is actually, this is over. Problem is over. But I am giving you a simplified thing, or ln is calculation intermediate steps I am giving you just for your satisfaction. Is 0.422 0.422 or P is sorry, since I have some space here, I am giving you this, or P is 2 times 10 to the minus 4, and log is actually e to the power of this gentleman called 1.525, and ends up in 3 10 to the power minus 4 atmosphere answer. Oh. So, yeah. Achha, here actually one thing I have very serious thing I missed out. I am writing this reference again with all respect to Professor Schumann Junior. I have already given you number of times this same reference. R. Schumann Junior. R. Schumann, MANN. This actual Purdue University question paper. I didn't get the. It is not a book actually, page number etc. Also it is actual exercise. Anyway, assignment problem. So this is the junior. This is the assignment. So answer is clear, or shall I write once more? So the vapor pressure is find that increase molar volume, calculate vapor pressure of zinc. So the vapor pressure of zinc is so the vapor pressure of zinc, right? Fully right, since you are writing zinc at, tell me, at 2500 atmosphere, and tell me temperature 693 Kelvin. Both common is 3.05 times 10 to the power minus 4 atmosphere. Once more right answer. This last line is last line. So this actually, you see one thing here you have to understand, that looks like it has increased from 2 times 10 to the power minus 4 to 3 times 10 to the minus 4. Looks like it 1.5 times increase. Looks like somewhat, but actually increase, if you see, effect of pressure on vapor pressure is small, because this is already so small. This is also equally small quantity. Absolute values are very small. 0.001 and 0.002 maybe 2 times, but both are very small. See, this is the answer. So with this we have solved this assignment number 7. So with this we have completed solving assignment number 7. Next, maybe one problem I will take, not this is over, this side is over. So I will actually take up, next job is actually take up the class test, third class test question paper is still pending. The one problem, at least if I cannot, there are four so, but one problem, the first one is the Hillingham diagram problem. I want to take up this. This will not take much time since the Hillingham diagram problem is not easy. So I am removing all this. I am removing all this. No more required. No more required. All settled. At least one job is satisfactorily completed. Now, if I can solve this, all gone. It's all gone. Quickly. It will not take much time. It is হচ্ছে our class test. Oh yeah. Our class test. Solution. Come on. What it says? The delta G0 versus T plot Hillingham diagram. Hillingham diagram. What I do? For the reaction. 2M solid plus O2 gas goes to 2MO solid, 2MO solid, okay, solid. Careful. MO solid is found to be linear. Yielding a slope of 100 joule per Kelvin. Yielding a slope of 100 joule per Kelvin. Slope of 100 joule per Kelvin, very good. The line intersects the delta G0 is zero line. The delta G0 is zero line at 800 Kelvin. Find what you have to find. A, how much heat will be liberated from liberated from or absorbed by the system when 1 mole of MO MO is formed, MO solid is formed by reacting M solid with oxygen O2 under a constant pressure of 1 atmosphere. This is the question A. B is what? B says at what PO2, partial pressure of oxygen, the metal M will oxidize at 500 Kelvin. Then question, solution. You just draw the Elingham diagram. This is delta G0 in Joule. This is the temperature, Kelvin. What happens? This is your linear curve. So this is your for example 0 value, and this delta G0 increasing this side means decreasing the other side, negative. This side is negative, that side is positive. Now what is given to you? First of all, what is given? Let me write the slope. Slope is 100 Joule per Kelvin. Slope 100 Joule per Kelvin. And another information is given that this line, this curve intersects this delta G0 is G line at a temperature of intersect 800 Kelvin. So that means if you drop this, this is 800 Kelvin. These two information. So slope is what? Recall? Good. Delta G0 is delta H0 minus T delta G, because reactants and products are the same temperature, so no problem. So slope is minus delta H0. Slope is what? How much? 100 Joule per Kelvin. 100 Joule per Kelvin is the slope, is minus, or delta H0 is what? Minus 100 Kelvin. At least this information. This is negative. What is the reaction? You may write at one place. That will be a good idea. The reaction is what? Right here. Reaction is what? Nicely write. 2M solid plus O2 gas goes to 2MO solid. You know, it is okay because 1 mole of oxygen must be in Elingham diagram. Okay, it cannot be otherwise. So slope delta is 0. So what is this? Now consider the reaction. Which reaction? Write nicely. 2M solid plus oxygen gas is 2MO solid. What is the delta G0? Right? As you know, delta G0 is delta H0 minus T delta H0. How much you can write? Delta H0, since delta H0 is minus, plus 100T. this you can write easily, okay? You write, and delta G0 is okay, not is, and when T is, write this now, when T is 900 Kelvin, what happens? What happens? Delta G0 becomes, see, when T is, what is the value of delta G0? Delta G0 is what? When T is 800 Kelvin, 800, let me take a look at this, 800, sorry, 800 Kelvin, then delta G0 is 0. If you have this information, then what you will get out of this? Out of this? Delta H0. So, or substitute 0 is delta H0 plus 100 into 800 gives you delta H0 is minus 80,000 joule. Okay, joule per mole of, okay, that you know how to write the mole, joule. Now question is, this will be heat. Why? Under constant pressure. Under constant pressure, delta H0 is the heat interaction. Under constant pressure, not under constant volume, but under constant pressure, and under constant volume, the internal energy is the heat interaction. So this will be answered by, for how many moles here? 2 moles of MO. But question is what? 1 mole. So write this nicely. So now for the reaction involving 1 mole, so write here for your way, just divided by 2, M solid plus half O2 gas is MO solid. What is the delta H0? Tell me. This stoichiometric, okay, extensive property, half, right, you write nicely, half of minus, so that why it is 40,000 will be very good, minus 40,000 joule. Now under constant pressure, right here, now under constant pressure, Q is delta H, which is actually delta H0 here. So Q is what? How much? Please tell me. Minus 40,000 joule. What is your interpretation of this Q? Question is, how much it will be liberated or absorbed, liberated from or absorbed by the system. So you have to answer that way. So what you will answer? Absorbed from the system or liberated. Negative means, actually, okay, negative. It will be rejected by the system. So that you should write. So what will be liberated from the system. Hence 40,000 joule of heat will be liberated from the system. Liberated from the system. Exothermic reaction, right here, it's okay. Exothermic reaction, right somewhere. Exothermic is somewhere, this additional comment not bad. Exothermic reaction. Over. Answer what? A. B. Part B. Part B, at what PO2 the metal will oxidize, that you have to answer. Okay, I am starting this. First you consider the reaction. For some reason I can consider this as well as this, but I am considering for this, for calculation is, consider the reaction 2M. You can consider either, any will do. 2MO solid is the delta G0. Okay, delta G0 you have to find out. Delta G0, check whether you have to find out. Delta G0, oh, by the expression is what? Expression, you tell me. What is the expression? Delta G0 is, right once more. Delta H0 minus T delta 0 though. So you complete this. What is the delta H0 for this reaction? Minus 80,000 for this direction. For this it is 40. For this minus T delta is for this direction. What is the slope value? So delta S0 is what is it? Minus plus 100T plus 100T. It's okay to plus 100T. So delta G0. So now what is the temperature? 500 Kelvin, or delta G0 500 Kelvin is how much? Tell me. Minus 80,000 plus 500 is minus 30,000. Good. Is what? Tell me. Minus RT ln K. RT ln K. Acha. Is what? R is what? 8.314. T is what? 500 ln K. I am writing this side. K is what? K is what? Acha, I write in, okay. Okay. Is right. I am writing. Minus, I am afraid whether it's out of screen. Minus 8.314 times 500 ln K. Ln K is what? You tell me. Activity of equilibrium constant. Activity of MO square by activity of M square PO2. Okay, this is it space required here, but that will be enough. You know, activity MO is a pure stuff 1, pure stuff 1. So you get on this, if you do this calculation, is what 30,000 this actually, or PO2 will be, you do yourself. PO2 will be what? What? Tell me. The calculation value is 7.34 times 10 to the minus 4. Right, nicely. 7.34 times 10 to the minus 4 atmosphere. PO2. So what will be answer? This is the question. This got a value. At what PO2 metal will oxidize? This is the equilibrium value. This will remain in equilibrium but not oxidize. Okay, M and O2 remain there. MO2 O2 remain there. MO2. So any pressure increase the pressure. Any pressure. So any pressure greater than what pressure? 7.3. Any pressure greater than any PO2. Any PO2 when pressure is not good. Any PO2 greater than 7.34 times 10 to the minus 4 atmosphere. Here, what will be answer? The metal question is what? Metal will oxidize. M will oxidize complete at 500 Kelvin. Answer. Interesting thing, one thing you see, very okay, important and interesting. At what is the PO2 value of this equilibrium? This equilibrium. What is the PO2 at a temperature of 500 Kelvin as we have calculated? What is the equilibrium value? 7.34 times. Very important. Awfully small. This is more important than this 7.34. Order is 10 to the minus 4. And when the temperature is 500. Wait, 800, what is this value? PO2 is what? This giving to intersects. This is not actually, you have written delta G0 is 0. What is the implication of delta G0 is 0? Is K is 1 ln K. 0 means RT ln K. K must be 1. K is 1 means these are all 1s already. PO2 is 1 atmosphere. So how partial pressure of oxygen, equilibrium of partial pressure of oxygen, which you call oxygen potential, increases dramatically from this low value of this at 500 Kelvin to 10 to the 4 times. 4 times, okay, 3.5 times, or 10 to the 4 times to a value of 1 at temperature 800 Kelvin. Why this? Because this is actually a logarithmic relationship. So move fast, okay, effect is fast. So this problem is solved. You feel tired a little bit? Another problem shall I take up? Second problem? Oh, that's good. And this is also allowing. The second problem. 4 problems are there. Second problem, let me complete this. This okay? So the second problem, let me write here. Problem 2. There are 3 problems. 2 problems. Problem 2. Next problem, problem 2. What it says, let me write. A sample of silver oxide, Ag2O, was placed in a tube furnace. Was placed in a tube furnace at 450 Kelvin and then air, which is 21% oxygen and 79% nitrogen was passed across the oxide, across the oxide at a flow rate slow enough to permit equilibrium. Between the solid and gas. PT, total pressure, PT is 0.9 atmosphere given. And what else? Calculate the change in mass. Calculate the change in mass. Change in mass in gram of the solid per mole of air passing through the tube furnace. Good. Tube furnace data given to you. 4 Ag solid plus O2 gas goes to 2 Ag2O solid, and delta G0 is given as -62200 plus 133.7 T joule. This is the data. Now we have to solve this problem. So let us remove this part because we have to draw a separate figure. Okay, that's is good enough. I think very good to manage here. Okay, in case we need solution. So you see, you actually let me sketch the problem. You have furnace here, as furnace, tube furnace. You are placed in a crucible. This is silver oxide. It is better I don't write inside. Silver oxide, solid. Powder. Silver solid powder or chunk. This is the temperature. This is the furnace. As you know, this is the furnace. This is the temperature is 450 Kelvin. What is being sent? Air. Oxygen 21%, nitrogen 79%. This is inlet. Inlet. What is this? Inlet, and then what is the outlet? It's the inlet. 20 SA. Temperature 450 Kelvin is okay. Everything is okay. Silver. So exit gas. Equilibrium gas. Equilibrium exit gas. Equilibrated gas coming out. What content? What it may contain obviously silver oxide dissociated into oxygen, and obviously nitrogen. Oxygen, nitrogen. What is the total pressure open to not open to atmosphere? Careful. If it were open to, then it will be 1 atmosphere. Since its pressure is given by some management 0.9 atmosphere, this is the problem. So question is actually how much mass will change or okay, change. If it dissociate, oxygen will be removed. And there is a drop in decrease in. Let us see. First of all, consider the pertinent reaction. Right. The pertinent reaction. Pertinent reaction is, tell me, you write other way. Silver oxide solid goes to 4Ag solid plus O2 gas, and you write here delta G0. What shall I write for delta G0? Tell me. I've reversed it. Reversed it because silver oxide will dissociate. The opposite. 62,200 minus 133.70 joule. Happy? Okay. Now I shall actually, we will consider or rather examine whether this will dissociate at all. Then the question of change in mass. So we find that delta G, okay, delta G at a temperature of 450, okay. So this is the one that I consider. So what is the equilibrium constant? Right. Delta G0 is minus RT ln K. Okay. Or delta G0, what temperature you are talking of? 450. Thank you. 450. 450 delta G0 is minus R is 8.314. This is all joule, you know. 450 ln K. K. Okay. K is what? I am coming to this. Achha, delta G0 450 is what? How much? Delta G0 from here. Will you write this? Delta G 450. You calculate delta G0 450 or substitute this here is what? 6220. I am just taking extra pen. 133.7 times 450 times 450 times 450. So this will be, let me write, since actually I have taken, 2035 joule. So please substitute, or 2035 is minus 8.314 times 450 times ln. K is what? Write nicely. PO2. Activity of oxygen means activity of Ag power 4. Okay, power 4 times PO2 equilibrium constant, product reactant activities by activity of Ag2 square. Now you know these are all solids. Pure solids means 1. So what you will get from this relation? PO2 equilibrium. No, careful. Negative is PO2. Then PO2 is less than 1. Significance is less than 1. If it were 1, then it will be like, see, PO2 equilibrium will be how much? If you calculate this, and you can very easily calculate 0.58 atmosphere. 0.58 atmosphere. Save this. This will give you actually all the equilibrium questions give you actually insight into the problem. Insight. You can judge the problem now. The equilibrium value you know. So, and what is Q? Actual. Actual. Q is what you write. Q is actual. Q2. Q is what? Q actual is what? Q, right. Q is what? Equilibrium constant is PO2 equilibrium. Q is what? PO2 actual. Equilibrium constant is what? PO2 equilibrium to is a moment ago. PO2 equilibrium. Then what will be the Q? It will follow this. Only actual. Only actual means factual. Practical. What is happening? Real. What is this value? Tell me PO2 actual. You tell me means what it is going into this PO2 actual. That it is that you are that this is exposed. 21% means mole fraction times the total pressure of 0.9. Good boy. Is 0.189 atmosphere. Now, so Q is less than K. So Q less than K for this reaction. The one Q less than K. So delta G will be. So delta G will be Q less than delta G is negative. So the reaction will be spontaneous. Reaction will be spontaneous means occur. That means you have a ground now to appreciate the problem. Oh, reaction will occur means silver oxide will dissociate. The moment it dissociates, you have to understand that it will liberate oxygen, and that oxygen will be carried. That is the loss. That is the loss. Silver that is produced will be here of everything. Okay, silver will not move away. Only the oxygen is the movable species. So hence there will be loss of this mass. Silver oxide will be transferred from silver. Silver will be removed from Ag2O, but it will remain in the form of. It will stay there. What cannot be retained? Oxygen. So oxygen loss. So quickly, so reaction spontaneous. Now you consider. We consider this. What is this? Or change in mass of the solid per mole of air. So you see. So now actually you consider this way. Hence this one. Right. Hence dissociation of silver oxide will occur until equilibrium. Until equilibrium means I am telling you. See, so spontaneous. So oxygen, it is throwing oxygen from lower value 0.19 to throwing. The moment actually it is enriched with oxygen sufficiently to reach 0.8 and no more 0.58. So this is until equilibrium. Okay, until equilibrium is okay. So I consider this actually. Hence, let start. So dissociate. So this is actually important. Let n moles of Ag2O will dissociate. Until equilibrium attained. So start the way you actually often start. Remove this part. I think it will be over here by this. You don't need any extra space. Very nicely, very easily. Very easy. Let me write. You write reaction, right? 2Ag2O. Molar basis, you write this 4Ag plus O2 gas. Huh? It's okay though. Now initially and at equilibrium, as you write always. Moles, in terms of moles, tell me. How many moles you have started with silver oxide? You don't know. We call it excess mole. So give M moles. But write excess means it will be retained. It will retain. Some will dissociate so much that, okay, it is excess. Best way, excess. And how much of silver you took? Initial state. It is coming initial state. Not equilibrium. No, reaction has not started yet. Initial. No silver. No silver. What is the oxygen content? What is the oxygen moles? Tell me. Per mole of air. 1 mole air. So oxygen is in the air 1%. Shall I write this? This is initial. Now the so 0.21 n mole oxygen. Additionally, you should write something. Point nitrogen. Oh, I've written underline n moles of silver oxide. You should say it. Wait a bit. I'm very sorry. I'm very sorry. 1 mole is given. Per mole of 1 mole is given. So how many it is? 1 mole. 1 mole basis, you have to answer in terms of 1 mole. Okay, so how many moles oxygen there initially? 0.21 is correct. N, why N? No N. 0.21. And nitrogen is what? N nitrogen? Nothing else. 1 mole basis. Because if it is 2 mole, you will double. Some basis is there. This is initial state. Equilibrium. When equilibrium has happened, what you have considered? N moles. Now you have considered N moles has dissociated. So M minus N, if you consider N, then how many moles of silver is produced? 2, 4. 2 dissociate, 4 N dissociate 2 N. And again, what is oxygen? Tell me. Oxygen? Half N, but will you write half N? Sure. No. 0.21 already there. Plus 0.5 N. Right. And nitrogen always inert, just diluent, inert, etc. So in total is how much? You write here. In total is often required. In total, in gas. Always remember this. In total is for gas always. Partial pressure relates to gas moles. Okay. In total is what? Tell me. You add this. N oxygen plus N nitrogen is how much it is? 1 plus 0.5 N. You don't have difficulty at all. Now write the equilibrium constant. Which temperature? The same temperature of 450 is what? Activity. Write our once again. Write activity Ag4 times PO2 times Ag2O whole squared. You know these are excess. This is produced pure. Silver is produced pure. Is there any alloy? No. So this is right here on pure. Right here. Write somewhere pure. Just in case I have not written anywhere. Everyone knows. PO2. Also always give actually. Even I forget, you don't forget equilibrium. This is equilibrium relation. Okay. So PO2 equilibrium. What is this value? PO2 equilibrium. PO2 equilibrium. K450 is how much? Tell me. K450 is how much? K450. You know very well what is the K450. You got this. 0.5. Right? Yes. K450. Right. That is K450 is 0.5. Sorry. Is 0.58. K450 is 0.58 what? No, it has no unit. Even constant has activity ratios. Activity has a ratio, no unit. But that is actually PO2 is 0.58 atmosphere. Is okay though. So right here it is 0.58. Nicely right. 0.58 is okay. No problem. 0.58. Okay, very good, very good. Acha, PO2 is what? Tell me, what is PO2? Tell me, NO2 by mole fraction times P total. Again, equilibrium. I'm writing equilibrium. Sometimes you don't write also, but you should understand that it here. So which value you will take up at equilibrium? Tell me what is the NO2 I shall write. I am almost done. NO2 what will write? So which line? Second line. What? Plus good boy. And in total? That's it. And into P total? 0.19. Don't take it for granted that P total is always 1 atmosphere. Giving the open atmosphere is 1. So you have everything done. Let me since few 1 or 2 lines. 0.9 or just I am giving the answer here. Plus 5n by 1 plus 0.5n is 0.58 by 0.9 is 0.64. 0.64. I have no difficulty. Or n is, if you do yourself, n is 2.33. Let me check. 2.39. Sorry, 2.39. N is what? Moles. So how many moles of silver oxide dissociate if you do this? As long as 1 mole has passed. 2.39 moles. How much loss? Weight loss. Weight loss. Will there be weight loss? Mass loss. Mass loss. Into the molecule weight. Of whom? Ag2. No. Ag never reduced. Ag never reduces solid stuff. It is loss. Ag2. No, Ag2 out. O is removed. Oxygen is removed. It is iron oxide reduction is nothing but removal of oxygen. Iron is not removed. So here, so right. So 0.39 mole of silver oxide will be reduced. Okay, is okay. Will reduce or dissociated. Dissociated will be correct term here because it is a dissociation. Will be dissociated. A little bit of unitary method. When you see, follow this logically. 1 mole Ag2O dissociate. Unitary. Dissociate into I am not writing, into silver and oxygen. Okay. Weight loss is weight or mass loss. Mass loss is how much? Tell me. Mass loss is weight loss. Give me weight loss or mass loss? Mass. Yeah, mass loss. Mass loss is mass loss is how much? 1 dissociate into, shall I write? Into silver and oxygen, right? Into silver and oxygen. Dissociate. Mass loss is good, very good. No. Check. Mass loss is correct. 1 mole silver oxide dissociate. How when it dissociates? What it dissociates? Acha, right. Says it helps you. Ag2O. Unitary method. 1 mole is 2Ag plus O. How much it is? Well, 2.39 mole. Mass loss is 16 times 2.39 is what? 38.2 gram. Answer. There's still two problems. Do you have any patience? Third, another one. Third I can do. Fourth, leave it. Fourth is actually maybe third problem. That's very good, very good, very good. Good patience. Third problem 3. Achha. Shall I remove this? Okay, first I remove this part. This is an interesting problem now. This is, if you solve this problem, you will have many problems of similar type. Then you can solve them. This is actually reference, good reference for many other problems, similar problem. Problem, what shall I write? 3. Problem 3. What it says, let me remove these pages are no longer required. Problem 3 is also very interesting. Again, Professor Schumann problem. Achha. It's okay. Problem 3. আচ্ছা, প্রবলেমটা কি চলে গেছে? আচ্ছা, রাইট। see this line? আচ্ছা, এখানে করে দিচ্ছি। নোট reference for problem what it was 2 third question solution. Problem 2 is A.E. Morris, but I am not sure. Check. A.E. Morris. A.E. Morris. A.E. Morris. But not sure. Check. Okay. Problem 3 says what? At 1700 Kelvin, 1700 Kelvin, it has been reported that silicon carbide solid and silicon solid are in equilibrium with a gas mixture consisting of 75% SiO and 25% CO at a total pressure of 0.02 atmosphere, given in the temperature range range 1500 to 1700 Kelvin the following standard enthalpies of formation. Standard enthalpies of formation. Okay, hang on. Of formation. What are these data? Here. Delta H0, right side. Delta H0 SiO gas. Silicon monoxide is a gas. Is what? Minus 100, minus 100, 420 joule per mole. Delta SiC, delta H0 silicon carbide, solid, minus 54390, minus 54390 joule per mole. And last is delta H0CO gas. Delta H0CO gas is 117,150, minus 117,150 joule per mole. Happy? Question A. Using the above data, calculate the ratio of SiO to CO. SiO to CO in a gas mixture. In a gas mixture at equilibrium with SiC solid, CC solid and Si solid at 1500 Kelvin. B. Calculate delta S0 for the following reaction. At 1500 Kelvin. The reaction SiC solid plus CO gas goes to Si solid plus SiO gas. Plus SiO gas goes to 2 Si solid plus CO gas. That's it. That's it. Very good. Let us solution. The pertinent equilibrium is A. I am answering the A part. The pertinent equilibrium is, as we guess from this, and the given also here is SiC solid plus SiO gas is 2 Si solid plus CO gas. Okay, it's very good. Now K 1700 degree centigrade, you have a data given as 1700. So find K 1700 degree centigrade. K 1700 you first find out, then you will find out K 1500 degree as required in the first part of the problem A. The K1700, K1700 first, let us see. This directly you write nicely. A equilibrium constant expression as we write often. Always PCO gas. I am actually saving time now since you are already expert. Take a look. Always I have a bad habit or good habit, and I also recommend my students equilibrium. In case you are not very confident, always write equilibrium. It should be equilibrium. Can only distinguish from the actual. So, what is the activity of SSC? 1. Produce pure. Pure, present pure, produce pure, etc. There is no option. And what is this value? This is either given, etc. produce, etc. So it is PCO by SIO. Okay. Anymore I am not writing equilibrium unnecessary. The equilibrium value is given to you, very good, 25% CO and 70%, so 0.25 by 0.75 percent means mole fraction. So shall I? It's okay, very good. This can be done. Unnecessary, I can explain, but unnecessary, partial pressure, mole fraction, always moles, total pressure, these are intertwined. So 1/3. So this part you have got this. Now your objective is to how to find. Next, you ask yourself as a K1500, because my question is not about 1700. Given 1700, question here is part is 1500. So K1500 you need to know. Then equilibrium ratio, etc. all can be obtained. How to find K? Then next, what is the relation? Popular relation that gives one temperature equilibrium constant to another temperature? Van 't Hoff equation. ddt ln K Van 't Hoff. Quickly, reference ddt. Tell me ddt ln K is delta H0 by RT square. Okay. Van 't Hoff is Gibbs Helmholtz, etc. from there. These are all related. ddt ln K. ddt ln K is delta H0 by RT square. Or integrating, or integrating, I am writing here, integrating here. Integrating, what the relation you know very well. Integrating, if you do this, everyone knows this. KT2 by KT1 is minus delta H0 by R. Considering delta H0 is independent of temperature, since it has given that in a certain temperature it is constant, so treat as a constant. 1 by T2 by this standard. Everyone knows this. 1 by T2 minus T1. Now what is T1? What is T2? T2 is the one that I want to find, means 1500. T1 is the 1700. Or K in terms of good boy. Thank you so much. This is the importance of students being present. ln K2. Good, very good, very good. I am very happy. Or right. All right. ln KT2 means what you write here nicely, 1500. What you write here, 1700. Okay. Minus delta H0 by R. R is what, your 8.314. What is the T2? Again 1500 minus 1700. Now here alongside note what is the delta H0? Note delta H0 is given to, tell me, reaction. See the reaction and delta H0. This reaction delta H0. For this reaction I am talking of. Delta H0 is what? As you know, data given. Good, very good. Try. Delta H0 is what for this reaction? Tell me. Very good. Minus delta H0 SIO. Good. Minus delta H0 SIC, first SIC perhaps, minus delta H0 SIO. All data are given to you. What is this value? Please write this, not bad. Minus 100, right? This one, minus 117, 150 first one, minus SIC plus SIO. Both I have written actually, which is first? SIC is first, SIO, this is SIO. So C, right? C is where? Plus 54,000, you check, plus SIO plus 114, okay? 140. If you do this, you get this value, that will be very helpful to you. Delta G value is 37,660 joule. Note, this is a very important note. Delta H normally is not a function of temperature. Delta H is equal, etc. No, is a function of temperature. Is a function. But here delta H note, delta G0 delta H0 is not function of temperature in the temperature range 1700 Kelvin as given. You have no responsibility. So what then this I am writing here. This means this will be used later. That's why I am doing now. Delta H0 for which temperature this is? 1500 maybe. Is a delta H0 17 maybe? Either is 37,660 joule. I am writing this was beforehand. So please come back. Write this. What is delta H0? 37,660 by 8.314 1 by 1500 1 by 1700. Acha. What is this? K1700 is how much? K1700 is 1 by 3. For this, if you get this, you get K1500, wasting time, not wasting time, K1500. Acha, I am writing K1500 by K1700. That will help you. K1500 by K1700. K1700. I am writing once more. I am not putting this. K1700 is okay. Is okay. I am retaining this. Is what? This the way I have done this is 0.7, just 0.7. Or K1700 is how much? Is a moment ago you said 1/3. 1/3. Or K1500 is how much? Tell me. 0.7 by 3. Happy? 0.7 by 3. Retain this form. I am not giving. It is what? It is what? Tell me. 0.7 by 3. It's perfect. 0.233 is right. If you are interested, 0.233. But I will use this 0.7 by 3. Now, what is the question? 1500. Question is what? Ratio. Find the ratio of SiO to CiO. What is the equilibrium constant? You know very well. Or what is the K1500? Tell me. Equilibrium constant is nothing but PCO by PSiO, or PCO by PSiO is 0.7 by 3. What is the question? Ratio of SiO2 or SiO to CO, or PSiO, PCO, how much? 3 by 0.7. 3 by 0.7 means what? 4.3 answer. Okay. What is it? Partial pressure means mole fraction means percentage. I am not writing this as the partial pressure. So 4.3 answers. Okay. Perfect. Last part, B. Last part will not, I think this space will be good enough, fortunately, hopefully. Calculate the delta is 0 for this reaction. So delta is 0. See, you have what you have here, delta is 0 for this reaction, delta G0 1500. You do this thing, you will get easily. Can you give an outline? This delta is 0 1500, all these things you have. Means equilibrium constant here. I am helping you. Equilibrium constant you have. Okay? Equilibrium constant you have. You have what you have, I tell you. Equilibrium constant you have, delta H0 you have. Delta G0 minus RTLN K. So you get. Equilibrium constant means delta G0, delta G means equilibrium constant. So you attack this way. So B, you actually let us proceed. Delta G, start this way. Delta G0 1500. Will you Baba? Is what? is minus RT ln K. All once right, then you write R 8.314. T is your 1500. Ln K is what again? K. You write. 1500 what I have written? K 1500 0.7 by 3. 0.7 by 3. 0.7 by 3. K 1500 0.7 by 3. 0.7 by 3 is 18,149 joule. 18,149 joule. একটা বড় হিসেবে। Now what is now right? Now good. Delta G0 1500 is nothing but delta G0 80. Sorry, 1500. Sorry, no hurry. We are almost finishing stage. Delta H0 1500 minus 1500 delta S0 1500. T delta S. That means how much this is? 18. This is right. Good. And what is this? Tell me. Next one. Same. Yeah, you have written all same. Any temperature you are interested. With the same value. This leads to delta S0 1500 is. ঠিক আছে তো ওখান থেকে নি পাবো। 149 is what? 13 joule per Kelvin. 13 joule per Kelvin answer B নাকি রে? ডাউন আরেকটা করে নিবি একবারে কত এখন কি আছে আনএক্সস্টেড গান আরেকটা কি একটু আরেকটা এখন আছে না কি ব্যাপার রে এতক্ষণ হচ্ছে এটা এত ক্ষমতা ভালো দিয়েছে আচ্ছা এটা আরেকটা আছে আউটলাইন দিয়ে শেষ করে দিই নাকি বলে তাহলে পুরোটা শেষ হয়ে যাবে তারপরে আমি সলিউশন নিজে করবো সলিউশন থার্মালিং শুরু হয়ে যাবে করে দিই না একটু এগুলো যখন পাচ্ছিস তোমার একটু সোজাই লাগে সরি ইউ অ্যাকচুয়ালি ফাইন্ড দিস ইজি আর last problem. It's okay to happy. Just have patience. 10 minutes. Actually, I need some time to write only. Otherwise, it's sorry. First remove this. Satisfactory, very satisfactory today. Today, how many problems we solve? Actually, roughly 4 that side and 4 here. Naki 8 problems is not matter of okay joke or say what I say. Not actually within our graphs. Okay, so this is problem 4, last problem. As for quickly and very quickly. I hope I will be very satisfied, but this will be the dead end. Consider the hydrogen reduction. Reduction of, but if it stops, it will stop. That you check that. Don't worry. A reduction of tin oxide at temperature below the melting point. At temperature below below the melting point. Below the melting point. Below the melting point of tin. Half SNO2 solid plus hydrogen gas goes to half tin solid plus H2O gas. The standard enthalpy of reaction, the standard enthalpy of reaction delta H0 is given by the following equation. By the following equation. Delta H0 is 53500 minus 17 point minus 17 point sorry let me write here. Note again, note problem, the reference for problem what ছিল 3 না problem 3 is problem 3 is নামটা R SCHUH Suman Junior. Problem 3. Reference for problem 3. Purdue University. One I can write Purdue University. Suman Junior. R Suman Junior. I have written RH. That's wrong. RH is maybe. Okay. Don't worry. Okay. Note. The problem for problem 3. Just note this. Now let us take up here. Take up 53,500 minus 17.0 T. This also similar reference. T plus 32 3.2 times 10 to the power minus 3 T to the power minus 2 minus 5.3 times 10 to the power minus 10 to the power 5 T inverse joule. 0 T 3.2 10 minus 3 T to the minus 2. Oh, sorry sir, T square. Very good. Then also the standard molar entropies. Also the standard molar entropies at 298 K are as follows. There is a chart here. Is 0 to 98 joule per mole per Kelvin. NO2 solid 52.3 H2 gas 130.5 SN solid 1.5 what else H2O gas 188.7 now A using the data given above find an equation giving delta S0 as a function of t. This is the first part. Second part, find the composition of a H2 gas mixture, gaseous mixture in equilibrium with Sn and SnO2 at 500 Kelvin. Okay. Problem over. Again, I am writing reference. Okay, H% or so many. Solution. পরিষ্কার হয়ে গেল। Start. Acha, I tell you one thing. See, there are variations of this problem. Sometimes delta G0 is given to you, 5 term. Then you have to find delta S0. Easiest. Why? How? dt of delta G0. That is there. As function of temperature, that is asked. Negative sign. And once these two are known, then delta H0 is from delta G0 is delta H0 minus T delta S0. So not difficult. So you have to, here delta G0 is not given, delta H0 is given. Even though you use Gibbs-Helmholtz, you have to see the integration. Okay, one you know means others are known. This is the message. Now see. So that's why it will be tricky. This is Gibbs-Helmholtz. You can Gibbs-Helmholtz. Equation quickly. What is the equation? You know, d. Tell me d delta G0 by T. You know very well. I remember this. dt is minus delta H0 by T square. This by T square. This is Gibbs-Helmholtz. Do you have no doubt about it? Huh? Okay. Is what? This is what? Achha. Minus delta H0 by T square. Try to get this first. Huh? This you do. Huh? Delta H0 is do this minus. Get minus and divided by T square. Term by term. 500 by T square. Happy? First term. Second term. Minus plus 17 by T. Happy? Third term. Minus 3.2 times 10 to the minus 3. T square cancel out. Is it? Delta H by T square with negative sign. And last one is minus plus 5.3 times 10 to the power 5 1 by TQ. By TQ. Not bad. Acha. If you do this, just I'm in one stroke I'm doing. I'm taking this dt to the other side. So I show it. Then d integrate. Oh, sorry. Don't. It's okay. Integrate. No problem. Integrate. If you integrate this side, you have to integrate the other side. I say, do the integration. No limits. You have to have it. Constant. You remember all this deal? Or what you get left hand side? Delta G0 by T. Simply. You keep on integrating. Acha. T to the 1 by dt by T square is minus 1 by T. Minus 1 means plus. Right, 1 by term you write without without actually okay, avoiding that. 17, good boy. 17 ln T plus 17 ln T. Minus bolo 3.2 T. এটা সাবধান। T to the power 3 minus 3 plus 1 minus 3 plus 1 minus 2 minus by 2 পড়বে বোধ একটা minus 3 plus 1 minus 3 plus 1 minus 2 একটা থাকবে তাই না, t to the minus 2 তো নাকি minus 2 and anything else integration I indefinite integration I is the IC নাকি রে I is এখানে লিখে দিই করবো বাবা I is integration constant হ্যাপি তো দেখি আমি একটু চেক করে নিই দিস ইজ ভেরি রিকোয়ার্ড হ্যাঁ 50 by t 17 LNT minus 3.2 10 to the minus 3t minus 2.65 10 to the 5 t square হ্যাঁ এটা হচ্ছে t প্লাস I আচ্ছা और डेल्टा जी जीरो करो बाबा और डेल्टा जी करो डेल्टा जीरो मल्टीप्लाई बाय t 530 रे प्लस बल 17 t ln t নাকি মাইনাস 3.2 10 to the minus 3 t স্কয়ার এটা 2.65 লিখতে পারি তো নাকি 10 to the 5 t to the inverse t inverse plus it it's okay very good in the quality equation one for some reasons I will use at the end and now how to next to find integration constant देखिए माथा काटा तो देखिए to find I normally I tell you if you knew I'm helping you if you will say if I know delta G0 at any given temperature then I can find I substitute this only I will be the unknowns you have this delta G as a function of temperature but what is giving you what is given to you as a function of temperature or at a yes as a function of temperature means at a given temperature delta G0 at a given temperature helps you not delta S0 giving at this temperature you can subtraction etc product minus reactant so but how you get delta S0 delta G0 that is delta H0 delta S0 and ddt of delta G0 is with negative sign is the delta S0 so from this I will get this okay see my point so first of all from this let me check here is it okay 17 minus 3.2 এটা দেখলাম না 3 points perfect next to find I delta S0 attack this minus ddt of delta G0 now quickly you are expert in this ddt so first term call this constant with negative sign মনে রাখবে minus 17 ln t plus 1 no doubt about it and the ddt of t square means 2t 6.4 times 10 to the minus 3 t inverse ddt of 1 by t minus 1 by t square নাকি রে so plus 1 by t square না by t square টা নিচে লিখে দিই বাবা অসুবিধা হবে কেন প্লাস বলো I প্লাস I নাকি এই ভুল করেছি সব এই লাস্টেটা ভুল করেছি নেগেটিভ সাইন একটা সবগুলো অ্যাড করে যাচ্ছে দেখ নেগেটিভ এই নেগেটিভ ভুল করেছি এটা হবে 2t প্লাস হবে রে এটা এই যে নেগেটিভ আছে অনেকগুলো সামলাতে হচ্ছে you have to differentiate as well as minus হ্যাঁ এখানে মাইনাসটা প্লাস করেছি নাকি না এটা ভুল করেছি এটাও মাইনাস হবে তাই না এটা ঠিক আছে তো বাবা হ্যাঁ মাইনাস প্লাস আগেন মাইনাস এটা ফার্স্ট ক্লাস হয়েছে ঠিক আছে তো ddSG সমান আচ্ছা সমান ইজ লাইক দ্য লাইন লিকেশন ঠিক আছে তো হয়ে গেছে আর এবার আমি তোকে বলি একটা কথা আচ্ছা ডেল্টা S0 298 এটা করে নে পাশে হোয়াট ইজ ডেল্টা নাও from the given data delta S0 298 করে ফেলো বাবা টুক করে ফেলো at least this time as temperature 290 দিয়েছে বলে ফেলো for the reaction under study হয়ে গেছে তো নাকি এই reaction under studyটা একটা লেখা উচিত ছিল কোথায় লিখেছি কি আমি কোশ্চেন আছে তো আছে ঠিক আছে তাই হোক না হ্যাঁ করো একটু বলো কি বলো ডেল্টা এস তুমি তো জানো এখন S0 H2O মাইনাস এস হাফ ঠিক হয়েছে একদম ঠিক হাফ ও এন্ট্রপি তো এটা তো কম্পাউন্ড আমাদের সব স্পিসিস গুলো দিয়ে দিয়েছে তো ইন্ডিভিজুয়াল নট ডেল্টা এস নট ইন টার্মস অফ ডেল্টা এস হিসেবে কারেক্ট ইউ রাইট হাফ S0 SN solid plus S0 H2O করো মাইনাস হাফ S0 SnO2 solid H2 ভ্যালুগুলো চট করে বসাতো বাবা কর হাফ S0 SN সলিডটা বলে যা আমাকে 51.5 ফার্স্ট টার্মটা 51.5 নাকি রে প্লাস S0 H2 টা কত বলে ফেল 88.7 না এটা তো হ্যাঁ ইউনিটেশন দুটো হয়ে গেল মাইনাস বল মাইনাস হাফ S0 SN হাফ 52.3 আর একটা বল আর একটা আছে বল হ্যাঁ minus S0 H2 I think it is correct তুই কর ভ্যালুটা অত দরকার নেই আর তোর দেখে নিই 188.7 হাফ 51 মাইনাস হাফ 51 একদম পারফেক্ট 57.8 দিকে ফেল জুল পার কেলভিন ঠিকই তো সো নাও এখান থেকে কর এখান থেকে কর so delta S0 I'm writing এখান থেকে কর 57.8 is কি বল delta S0 298 নাকি 298 নাকি 298 here substitute 298 here all the way you'll get what you'll get this gentleman called minus 114.93 and I the one unknown this leads to I is minus 172.73 minus 172.73 you all said so you write nicely what is the question find a question also find delta S0 as a function of temperature so you nicely লিখে ফেলো delta S0 লিখে ফেলো কত দেখো এখানে তুমি দেখো 70 অসুবিধা নেই তো এখানে আমি লিখে দিচ্ছি মাইনাস আচ্ছা আমি লিখেছি তাও করে 100 let me write this nicely 155.73 minus 17 ln t plus 6.4 10 to the minus 3t নাকি রে 6.4 10 minus 3 minus 2.6 10 to the power 5 t to the power minus 2 একদম বক্স কর আমি বলছি দাঁড়া এই যে অ্যান্সার কি জানো এই তো হ্যাঁ বলছি দাঁড়া বল এবার কি বলছি কেন হচ্ছে দেখ এই দেখ বাবা minus 17 আর মাইনাস আসে 100 this is the only thing that minus 17 plus 100 is okay তো minus 17 plus বাকিগুলো সব ঠিক আছে minus 17 ln t plus ফার্স্ট ক্লাস আছে সব ফার্স্ট ক্লাস আছে minus 2 অ্যান্সার হয়ে গেছে অ্যান্সার A এবার অ্যান্সার B নাকি খালি শেষ প্রবলেম শেষ অ্যান্সার বিটা করি এখানে একটু জায়গা একটু সরিয়ে দিন এটা আর লাগবে কিছু এখানে ডেল্টা জি এখানে আছে তো এটা একটু সরিয়ে দিই হ্যাঁ ফর্মুলাটা না সরিয়ে এখানে একটু অ্যান্সার বিটা করে দিচ্ছি বুঝলি বাবা আর কিছু করবো না এইটুকু থাক অ্যান্সার বি স্টার অ্যান্সার বি পার্ট বি এর কি আছে একটু চট করে ফেলবো লিখ রিঅ্যাকশনটা লিখতে হবে হাফ SnO2 সলিড এটা বেশিক্ষণ সময় লাগবে না H2S it will not take much time easy thing first delta G0 since equilibrium ratio equilibrium constant তাই না ফাইন্ড চেয়েছে না ratio at equilibrium ratio so equilibrium constant so means delta G0 কি করে পাবি you know very well delta G হবে solid relation তো রিলেশন লিখে ফেল একবার বল নাকি একবার লিখে ফেল তোর জন্য 53 ইকুয়েশন ফ্রম ইকুয়েশন 1 ফ্রম ইকুয়েশন 1 ওই জন্য ইকুয়েশন 1 নামটা একবার লিখে একবার 53 কপি কর 53,500 কুইকলি নট ব্যাড 17 TLNT 17 TLNT নাকি রে 17 TLNT minus 3.2 times 10 to the minus 3 T square minus 2.65 times 10 to the 5 T inverse তারপর কি লিখবো বল বাবা আইটা কত আইটা করে ফেলেছিস আই তো আর লিখবো না আই তো I have already found I. If I still there, I remains there. I is carried through. I is the integration constant. বলো না I minus 172.73. এটা তো কি বল আইটি হবে এন্ট্রপিতে তোমার টিটা আমার ডেল্টা জি ছিল দেখ না আইটি আছে হ্যাঁ আমি আইটি লিখিনি ও টি লিখেছেন এই তো টি লিখেছি দেখতে পাওয়া যাচ্ছে না 170.73 টি লিখেছি হ্যাঁ ঠিক আছে তো তাহলে তাও একবার করে দিচ্ছি দাঁড়া অতএব অর ডেল্টা জি জিরো কত টেম্পারেচার টেম্পারেচার 500 আর একবার করছি নে আরেকটা লাইন দিয়ে দিচ্ছি যে এই যে 500 করে ফেল প্লাস 17,500 ln 500 নাকি রে সব 500 বসিয়ে যা minus 3.2 10 to the power minus 3 500 square না 500 square minus 2.65 times 10 to the power times 10 to the power 5 500 inverse into 1 by 500 নাকি আর একটা আছে এখানে করে দিচ্ছি minus 172.73 times 500 ঠিক আছে তো একদম পারফেক্ট এবার আমি বুঝিয়ে দিচ্ছি হ্যাঁ এইগুলো আর কিছু লাগছে না সব মুছে দিচ্ছি হ্যাঁ সব মুছে দিচ্ছি কিচ্ছু লাগবে না সব শেষ প্রবলেম শেষ মুছে দিলাম রে লাইনটা লিখে হ্যাঁ মুছে দিলাম যে আর আবার লিখতে হবে और ওইটা মুছে দিলাম রে ছি ডেল্টা জি জিরো 500 53 না 500 বসিয়েছিলাম উপরে ও আচ্ছা এইটা উপরে আছে তো আরে বাঁচালি তুই আমাকে বাবা অনেক বাঁচিয়েছিস এখানে তো চলছে তো এইটা মুছে দিই না এটা আর দরকার কিছু দরকার নেই আর বুঝতে পারছিস এটা লাগবে না বলে ধরতে পারছিস সেটা অনেক ধরা এইটা মাইনাস আছে একটা আচ্ছা এবার 500 দিচ্ছি দাঁড়া 500 যদি এত করিস হাঙ্গামা 18,629 জুল নাকি রে ইজ হোয়াট কি বলবি বল তোর তো ইকুইলিব্রিয়াম কনস্ট্যান্ট দরকার ডেল্টা জি জিরো হয়ে গেছে ইজ মাইনাস আর টি এল এন কে একবার লিখ ইচ্ছা করে রিচুয়াল আর টি এল এন কে 500 is minus 8.314 500 ln k 500 k কে বলো বুদ্ধি করে বলো আমাকে কেটা বলো ইকুইলিব্রিয়াম কনস্ট্যান্ট এক্সপ্রেশন মনে রাখবে তাহলে বলো অ্যাক্টিভিটি অফ এসএন পাওয়ার হাফ পিএইচ ওটা কিছু কাজের হ্যাঁ বাই অ্যাক্টিভিটি অফ SnO2 পাওয়ার H2 আবার যথারীতি এখানে একটা ইকুইলিব্রিয়াম দিত আমার বদ স্বভাব খুব this is 1 that is also 1 so is actually আমার সঙ্গে ফলো করো একটু or তোকে কি চিন্তা করতে হবে না দরকার নেই or k 500 is যদি করিস 0.011 বাবা ঠিক আছে তো সমান কি কেটা কি হলো is pH2O by pH2 ইকুইলিব্রিয়াম কোনো অসুবিধা নেই তো এটা আমার মনে হয় কোনো অসুবিধা হবে না দেখে না আমি এই ক্যালকুলেশনটা করে নিয়েছি এখানটা, হ্যাঁ এখানে কে ফাইভারটা করে ফেলেছি একবার, কে ফাইভার এক্সপ্রেশন ঠিক আছে তো, এক্সপ্লেনেশন দিয়ে দিয়েছি পিএইচডি বাই পিএইচডি ইকুইভ্যালেন্ট। আচ্ছা আচ্ছা হ্যালো আছে তো, চলছে, শেষটা চলে আটকে গেল, ঠিক আছে ঠিক আছে, এর বন্ধ মানে গেল তো। আচ্ছা দুটো দেখতে হবে কেন, একটা দেখলে হবে না? আমি কি করবো তাহলে?
আমি তো এতক্ষণ এটাই দেখছিলাম, এখন গ্রিন লাইটটা জ্বলছে, এটা বন্ধ হয়ে গেছে।
না সেটা বলছিলাম, আমি যখন একা করবো তখন কি দেখবো তার?
আমি এটা পজ করছি।
ক্ষতি নেই, কতটা হচ্ছে